this is the second section of me trying to understand the MarI code and build it up according to the original code. So at the end of the last section, there was some issue with the code. I wasn't too sure how to update it so that it shows the information, display the draw the button, and later I realized that it's because there was some bug in the code, specifically being I am calling something that I didn't really define in my code. So therefore, in the Lua console, on the right side output, you'll see there's a lot of exception warning that something is null, and I didn't pay attention to it earlier. I can show the window. Let's see. This one. Oh, it doesn't look like it's showing up. Yeah, never mind. So basically, the Lua console where you run your script, on the right side there's output, and there was a list of exceptions. So specifically in the code, it's a couple of places. The first one is for the form part. I had a problem with when I run the code, the form didn't show up properly, and I was really confused. I thought it was something else that's causing problem, but actually the reason being there are specific functions and objects that are used in this button creation, form creation process, that they were not defined, and therefore this part basically runs an error. So I think we didn't really have pool created, and we don't have initialized pool, we don't have save pool, we don't have load pool. So I commented all of it out, and then now the form is able to display correctly with the remaining. Let me see if I can show it. I don't think it shows, but if you run the script yourself, you'll see a little window with some checkboxes for you to click, and now it only shows the ones that we have here, which is only a word and that's it. It's a label or a checkbox, and it's a word. Oh, this is the name of this is the text that display next to the checkbox, for example. And that was one reason the code crash. The other reason is here we defined we said network equals to genome network, but we never really create a genome network. Like, I have the function here, but I never run it. So this is another reason why it didn't work. That's why I have it commented out. So right now my display genome function is very simple. It's basically just to draw buttons A and B using the two colors, color 1 and color 2, which is defined here. So as you can see, in the, so there are two things. One is whether to hide the banner or not. The other one, so here you can see that I don't really understand the buttons, because in my mind they should work kind of independently, but it looks like you have to show the map first, and then you would hide or unhide the banner. That's how the logic is. And when you see show map, you see that you have a AB here. So if I hide the banner and I do show map, or I select show map, AB is still there. So there's something wrong with the code, I would say. Because AB is the neural network map. But anyways, we have two options. One is to show the banner or not. The other one is to show the map or not. And currently we only have the part about drawing the two buttons, which is right here. We set O to be the first one, one first, which is the first button. So now that button A, and then we draw it with a specific color, which you can see is blue. And then for the second button B, we draw it with a different color, which is black. So I think blue means active, and then black means not active. And let's go back to collect more info from the. Oh, I actually have to move this out. Let me just move that one instead. Okay, so now we want to create more content. So I think it's kind of weird because these two should be independent. If high banner is show, then you draw this box or not, right? And then if show network is checked, then you do display genome part, which is right here, which is the button A or B or not. But I don't know why it didn't really show the independent control of the two. Like one only works when the other one is checked or unchecked. I forgot what's the case. Okay, so anyways, let's go to the next part. We want to add more content here in the display genome. So let me find the part of the code. So the first part is drawing the cells in a neural network. And this is the code. This is the block of the code. And one thing that would not work is, so if I add this part of the code and I want to make my code still functioning, this part would break it because first we didn't really define a network neuron, so it's not going to work. So what we'll do is I will hard code it into something. Let's say 0. And then we go to the next part. Actually, I should make a note so then I know that I hard coded this part and I need to change it later. The alternative would be to initialize everything, to look at the code where we initialize stuff, and so that's when we call the things, we have them initialized, and I don't have to manually replace them with something. I think the majority content of this part is related to just drawing. So maybe that is a good idea. I will add a little bit to it first, and we can go to check out the initialization section. So this part, it should work. I'm going to run my code. And the thing is, you don't really see a difference because we're not drawing anything. And then I'm gonna add the bias cell. Actually, which is the part where I do, well, this is calling cells. I don't know, because like I think if anything, I probably want to add this section where it just goes through a loop and it draws out all the buttons, which is what I was doing here, but not in a for loop. So this is the code, and I made a note here before. Oh, actually, I put it here. There. So for buttons 1 to 8, color blue if it's active, I'm guessing. So we just defined, this is fine. So here, neurons max node value equals to this. This is not gonna work because, you know, we didn't really define this yet. So I am just going to remove this part and manually define the cell values. Instead of saying, oh, it equals to the value of the neuron list, I'm just gonna manually make up a number for it. And then we have cells, this equals the cell. And then if the value is bigger than 0, then I think this is blue. And the second case, it's black. So this is color 1 and this is color 2. And then we draw out all the buttons. So this is the part where I want to make sure it works. And I saved it, going to rerun it. Okay, so here you see that when I click show map, there's a bunch more buttons showing up: A, B, X, Y, up, down, left, right. I'm surprised it's so low. Maybe I don't think I changed the coordinate. The coordinate is what it is. So this part I also changed. Okay, so I think this is pretty good. We have the buttons drawn out, and I'm gonna look at initializing the first neural network, so we don't have to, you know, override stuff. We have a basic model to work with when it runs. So the part, let's see. Actually, there is some part of the code where it's drawing some more stuff, so I'll just add that part. add those parts in. So, you know, you have some boxes. So let me rerun again. Okay, yeah, so you see, I don't really know what the banner is. I think banner is to display some other info. Yeah, the map, you have a little box on the left side. Cool. Okay, so now let's look at initializing. This is probably done right here in the form, which is called initialize pool. So let's go find that guy. So what an initialize pool does is it does a couple things. I think I'll add it. I wonder if I want to add a numbering to the function so I know like, oh, is this on top of me or is it at the bottom of me, you know? Me try to do that. So that part, it's fine. This is function 1, function 2. Hope it's not too tedious. Function 3, function 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I'm tired. 18, 19, 20, 21, 22, 23, 24, 25, 26. Oh man, we're like halfway done. 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. If pool is no, then initialize pool. Interesting. This is just like a random block of text inside or outside a function. That's very random. 43, 44, 45. Hopefully I didn't like make a mistake somewhere. Wait, what's our number? 45, 46, 47, 48, 49, 50. Wow, without counting, I would never guess. There is so many. 51. And then we have a blob. Okay, so that's it. 51 functions. Oh, okay. So now we actually saw the initialize pool comments that randomly showed up in the middle of nowhere. Basically here, I probably need to find what numbers these are. These are like the first one, so like let's say this is up to number 5. Sigmoid is number 6. New pool is number 8. So I'm missing a number 7. I wonder if I should also I don't know, like record the functions that I have looked at, so I won't miss some other functions. Maybe number 10. Generate network. Number 16. Beijing number 45. I wonder if I put the comment there, or he had the comments. Anyway, so now what is initialized pool? So initialized pool is this one. Maybe having a list is a good idea. Let me think. I can put it in the Excel sheet. So 1 to how many? Like 50 something. 51. Yeah. Oh, okay. So basically, I want to record which ones I have did and which ones is like a partial. So 6 to 1 is done. Number 8 is done. Number 9 is done. Number 10 is done. Number 16 is working on it. Number 42 is done. And then 45 is working. Okay, cool. Oh, okay, so now we go back to initializing 38. So then I can like have know like where to stick my functions in after I number them. The initialized pool looks like this. Just copy it. It's really short. First we have pool equals to new pool, and then we have, I wonder if it's better to put this in like at the end instead of like close to here forms, instead of, you know, in the middle of a bunch of functions. For 1 to population, we defined it as 300. Basic equals to basic genome. We don't have this one. Add to species, basic, and then initialize run. So we don't have 1, 2, 3 things. Let's look at basic genome. The basic genome is pretty straightforward. You have genome equals to you initialize genome. Local innovation equals to 1. Genomes. So you need to have new genome. So you're running this section. You create this thing. Maximum neuron equals to inputs. What is input again? Return inputs. Function get inputs. Inputs is like a 0, 1, -1 thingy. I'm guessing. Which is kind of weird. Why would you define max neuron to be -1? I guess we'll figure it out later. So now you call the function mutate, and then you return. So we're working on number 12. And we're also working on number 38. Basically, right now I want to make something really simple without complicated ideas and made it work. Like at least, you know, draw the network with the most simple structure. That would be nice. So, okay, so now it is just it's doing mutate here. If it's a short function, then I'll use it. If it's like a long one, then I'll leave it. So it's kind of long. Let me just comment it out for now. So I'm not gonna mutate. The mutates, it has some mutation rates. It's defining the mutation rates, and it's still doing mutation rates, yada yada. Oh, actually, maybe it's not too bad. It also has other functions such as link mutate and no mutate, enable, disable. So it's kind of like, I think it's trying to, you know, mutate the genome. So if if you're, so there's different types of mutations, as we mentioned before. There's link, bias, connection, yada yada, node. And then this mutate function is saying, oh, if your probability to mutate for link is high, then you do the link mutation. If your probability of mutating for bias is high, then you do the bias mutation. That's kind of what it's saying. So it's not too bad. Obviously we, don't have anything. So what I can do is I can just take this part and I will create all these like little mutation functions, but actually like not doing them, not touching them yet. I'll just have like a empty shell, to keep them in, or we don't mutate for now and we just have a basic. So the next thing is we have add to species. So add to species, you would give it a child called basic. So you take a basic genome and then I guess basic genome is just creating a genome. And then with some chance of mutation in the mutate part. So this part is creating basic genome with chances of mutation. And then here we have a genome and then we add new genome to the species. And even just put it here. That's easy. So let's look at add species. So we have local species equals to false. So it's not too long. 36. S equals to 1 to the number of pools. That species. I think this is just like kind of inserting a species, so maybe not too bad. So we have a new genome. Find species is false. I think this is trying to identify if this is a new one or a existing one. So it's a false. If not a false, then you do this. Oh, so I think this is doing a comparison. So you just going through all the species and then you set something species equals to the in the the species in the list, and if not, if this is true, also first you assume you don't find a species. So if you don't find it and then you have a function that checks if they are the same, you check the child, and this is number 1, species.genome number 1. Then you insert the child into this species.genome list. Same species. I would think this would give a true Super Mario World, Yep. Oh, hey. Hey, 40. I'm looking at the code that somebody built to automate or build an AI that plays Mario. So this is found species equals to true. Big nerd. Hopefully I can figure out and make it do other things. Oh. Print hello world. Yeah, that's kind of the first thing I did. What's BNE? If not found species, if I if not, so this means if found species equals to false, didn't find species, then you probably wanted to add it. I'm a little bit confused with the logic of the code here. It seems counterintuitive. So basically you have a genome and then you want to see, hey, is this a new thing or a old one, right? So this is what find species is. So if this is not found, basically you want to say, oh, if this is a new, I'm gonna add it. If it's existing one, I probably don't do anything. As that's what I would think. Like, which is I guess what this is doing. If it's didn't find it, then you would create a new species, and then you would you know, insert this genome into this new species, and then you would add this species to the pool. So this is add new species into the species list, and then this is create a new species with the genome. That's what I would think it's trying to do. But then it's doing this thing as well in the for loop. So I guess there's a difference between species and a genome, and here is trying to see, oh, is this child or is this genome the same same as the first genome in the species? And if it's the same, then that means it is an existing species and you just add it to this species. I think that's what it's doing. So here is check if genome same species existing species. If so, add to the species. And then now you have, oh, it's true. So I think this is where you like organize the things so that they are structured, the things that are related to each other are together, and if they are different, then they Okay, so now we will look at the code for same species. So how would you define two species to be the same? And it looks pretty short, although it might be calling some other function. So it wants to see if so basically 36 we finished. Let me keep track of that. 36 is done. And this is 28. So 28 checks if they are the same species. So you have delta disjoint, which is probably a number up here. Yep. So this is to see how far away the genomes are with each other. Hi Drawable, how are you doing? This is to see how far away they are. Disjoint and weight are two other functions. And you have just two genomes and the genes inside them. Doing homework? No, I'm kind of like a side project, I guess. I'm learning the code for MarI AI to see how it works. This one's compare with two genomes from species. So this is just numbers. Disjoint is a function. You take the genes and then you compare them. So disjoint, let's look at disjoint. This is basically saying, oh, if it's very far away, then it's the same species, right? If close, then same species. This is like the distance. This distance of disjoint and distance of the weights, I guess. So disjoints. Not too long. 28, I would say this is done. It just has a lot of open-ended functions in it. Oh, too many functions. I'm tired already. Whoops. How long did I stream for? Oh my god, 43 minutes. Okay, so disjoints. Gene 1 and 2. This is only one gene, and if we look at the definition of gene, it's a list. And we don't have any specific about a gene. Anyways, so so when we're comparing, we grab .genes. Also, this is a list. So we actually don't have anything that defined a gene yet. So number of genes in the first one, number of genes in the second one. So gene is one item, and then what is this? This is a list, IL, and then gene innovation equals to true. We're back gonna check out. Okay. This is another list. Gene innovation equals to true. So gene dot innovation. So actually I didn't define the genes yet. So I have to do that. Oh man, why is there so many layers? The weird thing is we never define we never do like a new gene because we kind of started with initialized pool, right? Which is new pool. Do we have new pool actually? Yeah, new pool is right here. So new pool, you have pool dot something, right? And then you have a basic genome, sure. You add the species, and when you add the species, you are checking, is it a new one or is it an old one? And then when you are checking if they're new or old, you use the genes to check, but we never define genes, which is a bit weird. I do see a function called new gene. Actually, let me see where they actually called new gene. So they use it in copy gene, new gene, copy gene, link mutates. New link is a new gene. New generation doesn't, it's not related. This one is load file. Huh. Because I don't want to like go down too much of the rabbit hole. I wanted to make something simple that works first, and then we, you know, add it on. So basically here checking the if they're the same or not, it goes into like a gene thing. So I might like skip it for now because I didn't do gene stuff. I think I would just like here I would just say return false. So let's just say, hey, they're all different species. Oh, we return true to say they're all the same species. 28, it is not done. Because I don't want to go into the disjoint stuff yet. Let's see if it works. So that means here you always say yes, they're the same, so you just insert them. And then we have to do initialize run. The initialize run is not too bad in terms of the size of the code, but it has many other functions in it. Again, okay. But at least like we're out of the rabbit hole. With oh, when you need this, you need that thing, and then you need that thing, you need two other things, and that's just taking forever. So we're just gonna simplify it. So here, initialize run. First you have save state.load file name. Rightmost equals to 0. Pull the current frame equals to 0. And out equals to this clear joypad. So this is a function which should be pretty easy to get. It's right here. it's just setting it to false. Set all the buttons to false. That's fine. And then you have species equals to pool.species for current species, genome, pull the current genome, and then generate and evaluate current. So evaluate, we could potentially make it really simple. Generate network, we can also make it kind of simple. So I think I can keep number 40. Save state.load. This one I might need to check to see where we get that. Save state.load. Oh, that's like the only place it's being called. So I don't know. Well, maybe it was nothing then. I mean, it's the only place that's called. So we're gonna make a really easy version of this and this one. Like evaluate current, maybe just give 0 all the time. And then generate network. Okay, so actually, let me think. If I comment these two out, can I run it? Initialize network is being called in initialize pool. Initialize pool is being called when you don't have anything in pool. So this is where we first, you don't have anything, and then you want to initialize it. So is this good enough? Basically, probably not. Probably need to create network and stuff. That's why you need generate network. Okay, so let's do a very easy generate network. Oh, which is right here. Oh, actually, I had an easy version of generate network. So network is a list, network.neuron is a list, and then at the end you say genome.network is this network, and basically a empty list. It's an empty list. Your network is an empty list. I think I need to like add something to it. Empty list probably doesn't work. So for I equals to 1 to input, do network.neuron equals to new neuron. So this is the first thing that I did. I'm like always a bit confused with what input is. Whatever. Yeah, so it's a number, and then it's also, I guess, how many neurons you're gonna have. Maybe the input is, I'm guessing a button. It's an input, or something that describes what's going on right now. And the weird thing is, it's actually a number. It's not. Oh, actually, here this one. Input equals input size. Oh, so it's just a number. So this is 169 plus 1 equals to 170. So input is just the size of a radius or a square. I see. Okay, going back. Where were we? We're at 16. Okay, so this is, 1 to 170 pixels of a box. Your neurons, it's going to be a new neuron. Pretty cool. So you're creating a bunch of neurons. And then now for your output, your 1 to output. So this is like, as we mentioned before, 1 to 8 buttons. Your neurons is going to be max nodes. I think max nodes was like 1 million. Yeah, it's 1 million. Plus it's also more neurons. Okay, just creating more neurons. I don't really get it. Anyways, so now we do a table sort of genes function a b. Return a out less than b out. And so I think you are defining a function. So sort table using the function a dot out, b dot out. So again, we didn't really define genes. I'm supposed this means, hey, your genes has dot out in it. But anyways, it's just sorting the genes. And then let's look at the last part of here. Now we'll have a network. I'm gonna have to go back to make the genes, because again, I'm just doing a simple version of this so that my code works. It runs. That's a thing that I'm trying to do. Whew. Okay, let's look at the last part. For 1 to number of genes, gene equals to the ith gene. If it's enabled, then and then there's a condition. If gene.out is empty, then gene.out, you put a new neuron there. I think in and out is talking about where gene is like a connection, and then it has a starting point and an ending point. Starting point is in, ending point is out, and obviously they're neurons. So gene is defined by a beginning and an end. So here, neuron equals to gene.out. I'm guessing gene.out is like a number. I mean, it has to be a number. Although gene.out, yeah, it's a number. You're comparing how big it is. Table.inserts neuron.coming. You put, this gene into neuron.coming if so you define a neuron as the cave index of this neurons, and you put this gene inside this neuron incoming. What does that mean? What is neuron incoming? Oh, actually, well, your neuron is this guy. So you're saying this K or I've element of the neuron, and then the gene is in the incoming list. I'm guessing it means that everybody in here in the incoming list is where they ended up in this neuron. So everybody started from here, including this gene, and then, like for example, this is the incoming gene, and then it ended up here in this neuron. Let's say this is the incoming number 1, and then this is the out number 8. Then for the number 8 neuron, it keeps track of which neurons goes into it. So it adds number 1 into this incoming list, if that makes sense. Network neuron gene dot into. If it's null, then you create it. So again, this is the same. So you have gene dot into, and then you have gene dot out. I'm gonna assume into means starting point, although it kind of means the same thing. Into something, that means your destination. Out also means your destination, but I'm guessing into means this is where you started. If there's nothing that this gene is going into, then you put a new neuron there. I don't know. Just some guesses. So you generate a network. Okay, so now the last part is to create a evaluate current. So this one is getting kind of long, so I'm going to I am going to make it really short, and then I'll finish this video and then start a new one. So this is evaluate currents. You have species. I don't know why they always defined it. But I guess local is like, hey, I'm gonna save this temporarily inside a function so I don't have to write this whole thing. I just have to write this thing. So you have species and a genome. Inputs, you get a bunch of inputs. A controller, you evaluate network. So actually this is the part where it does the calculation. That's the one I'm gonna simplify to be 0. And genome.network, oh, welcome back. Genome.network. So this is the inputs. Yeah, we'll figure it out later. A controller, first player left and controller first player right, then set them into false. If they're pressing up and down at the same time, then you set both of them to false. I think that's what it means. You don't want the AI to be pressing opposite directions. At the same time, joypad.set controller. I think this is a, oops, like an internal default program. Yeah, you don't have to do anything for it. Okay, cool. So now I just need to make this guy really easy. Oops. So this is maybe it's not too bad. Evaluate the network. Number 17. I don't want it to be like really long, really complicated. It's gonna be really hard to debug if it's too long. So here, evaluate the network. You have network and then you have some input. You insert number 1 into your inputs. And if the number of inputs is approximately inputs, so this is a small number input, and this is the big number, which is the 170. That means incorrect number of neural network inputs. And then you return blank. If 1 to 170, you set the value equals to the inputs. Okay. So actually, what was the input again? Evaluate network. So it's taking input. And what's inputs? Yeah, here. Which is here when you are saying, hey, it equals to -1. Hey, this equals to -1. It equals to 1 or equals to 0. Which I think that's what it means. It's, 0, 1, -1. Okay, where am I? Number 17, right here. So 1 to 170. If there's too many inputs, you don't want that. That values to, and then for each pair, I think pair is like a dictionary where you have the key and the value. I think it gives you the index. So in this example, you don't have anything at the front. You only have neuron. Are you buying Overwatch 2? I thought it's free for people who already have Overwatch 1. I don't know if I want to buy it. So J equals to 1, number of neurons. I honestly don't know. I have a lot of people ask me if I'm buying it. I stopped following Overwatch. Incoming, other, some incoming weight plus other value, incoming value, sigmoid sum. Yeah, it's kind of long. P1 buttons max no bigger than 0, button true, button false, return output. So evaluate network, I would guess it give a number, but maybe it doesn't. Oh, actually evaluate network comes from the controller is the output. So it's telling you what controller it's what controller it's doing. So we go back here again. It's more like, I actually don't know. So you return the output, which is right here. So what is these like neuron value stuff for? Oh, I think you add it up to see if it's bigger than 0, then you set it to true. So again, output is buttons 1 to 8. So first you have button is P1 and then the button name, and you have the neurons add up, then it's true, otherwise it's false. But the thing is, network.neuron, it doesn't have anything. Oh, actually it has the O here, max nodes plus O dot value. So this neuron value is going to be determining if you're pressing it or not. So this is basically determine if learn to speak French. That's cool. Is pressing which buttons? Very hard. Yeah. Hope you have fun though. Kind of tired. Let's speaker practice with. Yeah, that's one hard thing when you don't really use it. Network.neurons.value. You can like try to stream and then talk in it. I see some people do that when they learn English. I would do that. Keep myself entertained. But there might not be a viewer who will join my stream. Well, you are saying it, pretending there's somebody watching you. Doesn't have to be anybody. If you depend on other people to watch you, then you never practice. So just practice as if somebody's watching you. That's why I'm also like recording this study session. So I feel like, you know, even if nobody's watching it now, maybe they'll watch it later on YouTube. Or maybe I'll watch it later myself. Network neuron value. And how do you set the value? So you set it here. So first you do inputs, which I don't think it matters because it's not the right index, right? Like, yeah, sure, your value is that, which I don't really get why it's setting it like that. here for j equals to 1, a number of neurons incoming, incoming equals to neuron dot incoming j, other equals to network neurons incoming into some. So you have incoming and then you have other. This is the incoming neurons, and then this is the incoming dot into. I don't remember defining its neurons and incoming intos. Might be something I have to add on later. Definitely was not in my definition. Like, did we define network? So we have neurons is a list, but then what is incoming dot into? Right, incoming is neuron dot incoming. Did we define neuron dot incoming before? We have neuron dot incoming here. But I don't think I initiated it before. So like the incoming and stuff, it's a bit confusing. So actually there's a function called new neuron. Oh, we actually didn't define this. That's where it does the incoming and the value. Forgot to define this one. It's 15. So a neuron, you have incoming and value. Value is 0, incoming is a list. And basically here, this is where you are adding it to this list. You're saying, that's why we also have to define the gene. I didn't do that yet. So if the gene is enabled, then you look at what is gene.out and what is gene.into. So if gene.out is null, then you stick a new guy here, and gene.out is like a number, which is, I guess, kind of weird. So a neuron is like a specific one, and you stick it in this incoming list. So you actually say, hey, if the gene is enabled, then I am going to just stick it in. It doesn't matter what's going on here. And you kind of just stick this enable gene into this, which is identically this guy's neuron, this specific neuron's incoming list. Oh, I think it has too much stuff. I kind of want to remove. So like if it's calling something new, I'm gonna remove it. Like for example, so here, this guy, network neuron, like if I didn't define it earlier, I'm not gonna define it now because I'm tired. Also, I don't think my code would run because I didn't define gene, because all your gene.into stuff, this has to be defined. But other than that, so here we have network.neuron if value. So each little guy is a new neuron, which we defined right here, and it has a value, and then it has a incoming. And then so the thing is, incoming actually has dot into, where it's not shown here. It only has incoming, right? It doesn't have dot into. So what is this dot into thing? Where did it come from? It also has to be defined. It's probably to keep track of like the connection between the nodes. Like, yeah, sure, you have nodes number 1 and number 2 and number 3 and number 5, but what is their connection? Like, is this, number 1 goes to number 2, number 1 goes to number 5, number 2 goes to number 5? Like, we don't know. That's where the into thing is for. Oof. So it's a lot of stuff. There's more to go. And so I think neuron that value is fine. Neurons we defined it, which is fine. The incoming stuff, let me check, because basically, like, look, incoming has dot into, it has dot weight. That's not defined anywhere. So either we look at the code for it, or we simplify it to some random stuff, and and leave it as that. So basically it didn't find anything. So nobody knows what this incoming dot into is. That's kind of weird. So the incoming is a neuron. What about dot into? Maybe it's not called the incoming. Yeah. So I think it's a gene. Yeah, so it looks like it's a new gene that I did not I didn't define. Number 13 right here. So now this makes more sense because regarding the fancy names, it's basically just genes. So gene, you have into, you have out, they're all numbers. You have weight, you have enable, and then you have innovation. So now we know that But obviously, gene is different from a neuron. And I think a neuron has incoming. I think it has genes. Neuron has genes, which is kind of weird because I would see a node, but is a node a gene? Is it a neuron? I'm not sure. So anyways, here I'm thinking when they did, yes, sure, you are a neuron. And what is a neuron? It is a list, but it has two features. It has an incoming and it has a value. So an incoming is a list, and you inserted a gene into this list. So this is actually list of genes. List of genes in neuron.incoming. And then your gene also it has into and it has out. But they're all numbers, weirdly. They're all 0 to begin with. This is like sorting them based on their out value. So every gene has a out number, and it's always set to 0 at first. But then when is it out? Like when is it updated? I don't know. Maybe it's from like some other part of the code. Where they updated. But anyways, incoming is just a list of genes. One gene from a list of genes, and then other one genes into and then you do like a sum incoming the weight of the gene and the into's value. It's kind of weird that they say other dot value because other oh actually this is a gene. Other gene equals to right now it's a gene's value. It does some like calculation thing. And it gets a sum. Number of incoming is bigger, then you do a sigmoid of the sum. So you change it to, this is probably like change number to 0 to 1. So you make this neuron a number that's between 0 to 1. Okay, I think I'm done for now. Let's just run the script. Like it might not run, I mentioned before, but let's just try to run it and then see what happens. Okay, so the button still works, and I'm able to like wander around. Do I know if the code works or did it like break or anything? Not really. Actually, so regarding display, we actually didn't call anything. Actually, we did initialize pool. So if the restart button works, that means the rest of the code works, which I doubt it would. Ooh, it actually not bad. So it says could not find a file called dp1 states. Wait, so do I not have dp1.states? Because doing save state.low file name, and do we define file name somewhere? Yeah, dp1.state. So it says it cannot find dp1.state even though it's like right here. Oh, needs the pull, which is right here. Actually, it's initialize pool, initialize run, file name. File name is .state. So the problem is it's saying it cannot find it. I don't know. Maybe like right here. It's in both folders. So it looks like there's like no other problem other than it can't find the file, which is even more weird because it should have the file right here. Unless it's looking for it in here, which it also have it. Oh, actually, SNS. I think that was one of the issue before. Okay, anyways, let me stop the recording. Thanks for watching.